Okay, so today we're going to talk about solving polynomial equations where we have degree 3 or higher, so they're not linear or quadratic. Um, and usually what that means is we have to factor it and break it down into factors that are either linear or quadratic because we know how to get the zeros for those. Um, and usually that means we have to make some guesses, some intelligent guesses, hopefully, about potential factors, and then we use division, either synthetic division or long division, to check to see if those potential factors are actual factors. So there's two basic ways. One way we do this is by graphing the function and looking where it crosses the x-axis, and if it crosses at points we can identify, then we can use those as roots, and that lets us find factors. The other way is the rational root theorem, and that's what we're going to learn about today. So with the rational root theorem, we have to deal with rational numbers. And rational numbers are any numbers where you have an integer over an integer. So fraction like 3/5, but also like -7, because that's -7 over 1. 5 is a rational number. 2/13 is a rational number. 534 over 717 is a rational number. And what the rational root theorem says is that if you have a polynomial, if you take the first coefficient and get all the possible factors of the first coefficient and all the possible factors of the last coefficient, then the rational roots will be one of the factors of the last coefficient over one of the factors of the first coefficient. All right. At this point, that probably sounds a little bit weird. So let's try an example, because I think with an example, we'll be able to see this. So let's say that we have 2x cubed minus x squared minus 8x plus 4 equals 0. So this is the equation that we're trying to solve. All right? So we want to find the factors of 2 and the factors of 4. So the factors of 2 are plus or minus 1 and plus or minus 2. And the factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. Because 2 can be 1 times 2. That's basically it. So, and they could be either positive or negative. And 4, the factors, you could have 2 times 2 or 1 times 4. So factors are 1, 2, and 4. So our roots would be plus or minus 1, plus or minus 2, or plus or minus 4 over plus or minus 1 or plus or minus 2. Right? All the factors of the first coefficient divided by all the factors of the second coefficient. So that means we could have 1 over 1, 2 over 1, or 4 over 1. Or we could have 1 over 2, right? Or we could have 2 over 2, but that's just 1, or 4 over 2, and that's just 2. So this is all of the possible rational roots. Okay? Well, I'm going to look at this with, there's 3 factors, and it multiplies out to be it multiplies out to be 4. So I'm going to take a guess that there's a good chance that one of the factors is positive 2 or negative 2. So let's assume that it's positive 2, right? So we're going to use synthetic division that we just learned about. So x minus 2 is a factor. So we get positive 2 here. And then we get 2x squared minus 1x cubed minus 8x plus 4 right here. And we can do synthetic division on this. I don't like that line, so let's draw another one. There we go. All right, so we pull down the 2. 2 times 2 Now, actually, we're going to put negative 2 here. We're going to try with negative 2. Let me backtrack a little bit. We're going to we'll try negative 2 there, so we're going to go with a potential factor of x plus 2. So we'll put on the 2. Negative 2 times 2 is negative 4. So we get negative 5 here. And then negative 2 times negative 5 is 10. Whoops. Get 10. We add negative 8 and 10. That gives us 2. Negative 2 times 2 is negative 4. Negative 4. We add those together, we get 0. So there's 0 for the remainder. So that means that if this is minus 2, that x plus 2 is a factor. And then we have 2x squared minus 5x plus 2 is also a factor. So now, if we can either use the quadratic formula or we can factor that, and it turns out that we can factor that 2x squared minus 5x plus 2 is equal to 2x minus 1 and x minus 2. All right, so that means our total factor here of 2x cubed minus x squared minus 8x plus 4 is equal to x plus 2 from up there times 2x minus 1 times x minus 2. So that means x equals negative 2, x equals 1/2, or x equals 2. And we've solved that polynomial equation. We have the 3 possible roots, and it's third degree, so that's how many roots it has. Right? So let's try another example. So we get 3x cubed minus 2x squared minus 11x plus 10 is equal to 0. So let's go for the factors of 10, which would be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And the factors of 3, plus or minus 1, plus or minus 3. So that means our possible roots are plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, all over plus or minus 1, plus or minus 3. So we could have 1, 2, 5, or 10 over 1, so we get plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, and then plus or minus 1/3, plus or minus 2/3, plus or minus 5/3, plus or minus 10/3. Let me write that in red so it shows up. Plus or minus 10/3 there. So those are the possible roots. Well, now we know the last term is negative 10. Or positive 10. Sorry. And the degree is 3. So there's 3 factors which multiply out to be 10. So there is a really good chance that it's going to be, well, it's going to have to be like 1 times 2 times 5 or 1 times 1 times 10. So there is a really good, there's a really good chance that one of the factors is going to be 1. So that one of the roots will be, those second numbers is going to be 1. So let's try doing this again, we will have 1 there. So we're going to look at x minus 1 as a potential factor. And we have 3x cubed minus 2x squared minus 11x plus 10. We draw on our line. So we pull down the 3. 1 times 3 is 3. Negative 2 plus 3. I should just give up on this. Negative 2 plus 3 is 1. 1 times 1 is 1. Negative 11 plus 1 is negative 10. 1 times negative 10 is negative 10, and negative 10 plus negative 10 is 0. So again, 0 remainder means that is a factor. So we're going to have x minus 1 times 3x squared plus x minus 10. Now, there's a couple ways we can go with this. 1, we can just factor. I'm looking at this and I can tell that 3x squared plus x minus 10 is equal to x plus 2 times 3x minus 5. So that's one way when we get that quadratic. We can just factor it, and we'll have x minus 1 times x plus 2 times 3x minus 5. But we could also apply the rational root theorem again. So we could try negative 1, we could try 2 or negative 2, 5 or negative 5, 10 or negative 10, plus or minus 1/3, plus or minus 2/3, plus or minus 5/3. So we can try that. And sometimes that's the only thing to do now is just to make another intelligent guess. Or we can note, hey, this is a quadratic, right? We have 3x squared plus x minus 10. We can use the quadratic formula on that. So if we use the quadratic formula, we get negative 1 plus or minus the square root of 1 squared minus 4 times 3 times negative 10 over 2 times 3. So we get negative 1 plus or minus the square root of 1 plus 120, so square root of 121 over 6, which is negative 1 plus or minus 11 over 6. So we get either negative 12 over 6 or positive 10 over 6. And those negative 12 over 6 simplifies to negative 2, and 10 over 6 simplifies to 5/3. And notice that those are both in our list of possible rational roots. So if we had used b, we would have eventually gotten there. But this gets it to us really quickly. So this tells us that we have x minus 1 times x plus 2, because that negative 2, and then 5x minus 3, because 5/3 is the other factor. And this gives us our solution, because that means x equals 1, negative 2, or 5/3. And that's how we use the rational root theorem. And there's a couple more examples here for you to try on your own.